Hello everyone, my name is Devanshu and I'm back with another chapter which is power play. So first of all, have you ever wondered how people calculate huge numbers like 2 followed by 10 zeros or 1 followed by 100 zeros without multiplying them again and again? So the basic secret lies in a beautiful concept of mathematics which is called exponents and powers. This is what we are going to discuss in this particular chapter. In the next few minutes, you will understand this topic in the simplest way possible with easy examples, smart tricks, and questions that frequently appear in your examination. So grab your notebooks and we'll start with the chapter. There's a very usual question, or a lot of people ask this question, that how many times a sheet of paper can be folded. So a lot of people answer to this question that at most 7 times or 8 times it can be done. So let's try to understand what is the basic mathematics behind it. So as you can see, let's assume that the thickness of the paper is 0.002 centimeters. When you fold it once, it will become double, will become 0.004. When you again do the same thing, it will become 0.008. 4 times fold will become 0.016, then it will become 5 times fold, 3, 2, then 6, 4, then 1, 2, 8, 0. Basically, when you reach as many as 20 folds, the thickness of the paper will become 10.4 meters. 10 meters is basically the height of a ceiling, not even 10 meters. 10 meters is huge. Okay, so that is something we need to understand, that basically when you fold, the thickness will not add up, it will become double of itself. Okay, so every time you are multiplying the thickness by a power of 2. First time you are folding, you will multiply it by 2. Second time you are folding, you will multiply it by 2 to the power 2 or 4. Third time you are multiplying, you will multiply it by 8, and so on and so forth. So that's the reason every time you fold it, it becomes double, and it is an exponential growth. Okay. So first of all, let's see what is exponents. Okay. In the first chapter, which is squares and cubes, we have seen this particular notation where we have written 4 to the power 2, right? Now, try to understand this thing. What is it called? So, like the example that they have taken 5 to the power 4. It can be called in several ways. For example, 5 raised to the power 4, 5 to the power 4, 5 power 4, fourth power of 5. You can call it in any way, but the notation is going to be there is a base, there's an exponent. Okay, the base is going to get multiplied to itself this many times. So this is nothing but 5 into 5 into 5 into 5. This is the basic understanding of exponent, and try to understand this thing that the reason why we use exponents is to reduce the effort of writing. For example, if I have to write a number 1 followed by 10 zeros, right? Now I have to use it in the calculation. Every time I have to write it down again and again, do the multiplication, addition, everything. It is going to be very difficult. Instead of that, what will I do? I'll write it like this much. This will help me reduce the effort of writing, and to some context, it will help me reduce the effort of calculation also in multiplication and division. Let's try to understand when the bases are negative and when the bases are positive. Always remember this thing that if I talk about a number, let's say 4, 4 to the power 2. This can be written as 4 multiplied by 4. I'll write minus 4 to the power 2. Can be written as minus 4 multiplied by minus 4. And we already know when there are two negatives getting multiplied to each other, they will cancel it out and will become a positive number. Both of them will result into the same number, which is positive 16. Always remember this thing that whenever the base is positive or negative, raised to a power of even number, when this exponent is even, the final answer is going to be positive always. Okay. Whenever there is a base raised to a power of even, it will result in a positive number. When the base raised to a power of odd number, it can be a positive or a negative number depending on the sign of the base. If the base is positive raised to a power of odd, it will be positive, the final answer. When the base is negative raised to a power of odd number, the final answer will be negative as it is. Okay. Then writing a number in exponential format. This is basically, in our last chapter, we have talked about prime factorization. This is nothing but prime factorization. So 3, 2, 4, 0, we prime factorize it. 2, 1, 2, 6, 12, 2, 0, 0. Then 8, 1, 0. Then multiple times you will do the same thing. And finally, your 32400 will come out to be 2 multiplied by itself 4 times, 5 multiplied by itself 2 times, and 3 multiplied by itself 4 times. That's why it is written that it is equal to 2 to the power 4 into 5 to the power 2 into 3 to the power 4. This is basically the exponential format of writing a number, or in the prime factorized form. Next. Now let's try to understand what are the laws of exponents, which is going to be the most important part of this lecture. Okay, what are the laws of exponents? So, like I said in the starting, it reduces the effort of writing as well as calculation, because we have thought of the different laws of exponents. So first law, it is basically when the bases are same, the powers will get added. So for example, 3 to the power 2 multiplied by 3 to the power 3. This is nothing but 3 into 3, 3 to the power 3, and 3 into 3 into 3, that is 3 to the power 3. How many 3's are visible to me? This is basically 3 to the power 5. So can I say this is 3 to the power 5? It is nothing but the addition of the powers. Always remember, when the bases are same, the powers will get added. So n to the power a into n to the power b, the bases are same. The powers will get added if there is a multiplication happening. That is the first law. Okay. When the bases are same, the powers will get added if there is a multiplication happening. The second law, a power raised to another power. So for example, 2 to the power 3 whole to the power 4. This is, in this basically, can I write it as 2 into 2 into 2 whole to the power 4? And each of these 2 will be written 4 times further. So 4 times this, 4 times this, 4 times this. How many times in total can I say there are 12 2's in the picture? So you can basically multiply both the powers. It will become 3 into 4, 12. Please do not get confused this with 2 to the power 3 to the power 4. Try to understand this thing, that these two are entirely different things. In this one, this power of 4 is raised over the entire number 2 to the power 3. Okay. This is what the formula is about. In this one, the power 4 is raised over the lower power, or the previous power. So try to understand. 2 to the power 3 whole to the power 4 versus 2 to the power 3 to the power 4. In this 4 is raised over the entire number, which is 2 to the power 3, and this will be equal to 2 to the power 12. On the other hand, in the second one, the 4 is raised over the power of 3. So 3 to the power 4 is 81. This is 2 to the power 81. These are entirely different numbers. And remember, whenever you need to multiply the powers inside and outside, you'll have to look at the brackets. You can do this only when the brackets are present, not for this one. Okay. Now, when the exponent is same but the bases are different, we have seen when the base is same, exponents are different, multiplication is happening, you can add the powers. But what if it is the other way around? When the exponents are same, for example, 2 to the power 3 into 2 to the 3 to the power 3. Now the exponents are same, but the bases are different. In this, you will take the power out as common. It will become 2 into 3 whole to the power 3. So this is what is written here, m to the power a into n to the power a. In this, the bases are different, but the powers are same. So it will become m into n whole to the power a. Okay, perfect. Now let's move on to the next part, which is on the division front. So we have talked about when the bases are same but the powers are different, multiplication. When the powers are same but the bases are different, again multiplication. When there is a power number and on the bracket outside there is another power that we have seen. Now look at division also when the bases are same but the division is happening. So let's say 3 to the power 5 divided by 3 to the power 2. Now the bases are same. When multiplication was happening, we used to add the bases. When division happens, we will subtract the bases. So that's why n to the power a divided by n to the power b is equal to n to the power a minus b, right? Always remember one more thing, that any number raised to a power of 0 is always equal to 1. So 5 to the power 0 is 1, 6 to the power 0 is 1, 5, 2, 8, 6, 9, 1, 4 to the power 0 is 1. So any number raised to a power of 0 is basically equal to 1. Now, what if there is a negative exponent in the picture? Negative exponent. So for example, I'll write 5 to the power 2 and 5 to the power minus 2. 5 to the power 2 is 5 into 5. If there is a negative sign in the exponent, that doesn't mean that the number is negative. Negative just shows that you have to do the reciprocal of the number to convert it into a positive number. So this is basically 1 upon 5 to the power 2, which is 1 upon 25. Negative denotes that you have to do the reciprocal of the number, nothing else. Negative in the power doesn't change the sign of the number. Okay, perfect. Now, these are the things that we have just discussed. So first one, when the bases are same, the powers will get added if there's a multiplication happening. When the bases are same, the powers will get subtracted when the division is happening. Similarly, when the powers are same, when the powers are same, the bases, when the powers are same and the bases are different, the power will get outside as common. So m to the power a multiplied by n to the power a is equal to m multiplied by n whole to the power a. Same goes for division. M to the power a divided by n to the power a is equal to m divided by n whole to the power a. Anything raised to a power of 0 is equal to 1. Negative power means do the reciprocal of the number to convert it into a positive power. Yeah, this was all about the laws of exponent. Okay. Now let's try to understand the power of 10 and the scientific notation. Scientific, so there is an expanded form, there is a scientific notation. So let's try to understand it. Let's take a number. Let's say that the number is 49623. Now, this is the number that we are talking about. First of all, expanded or the general form. Expanded form or the general form. This number will be written as in the form of its place unit. Okay, so for example, this is 49,623. So this is basically at the 10,000th place. So 4 into 10,000. 9 is at the 1000th place. 9 into 1000. 6 at the 100th place. 6 into 100. 2 at the 10th place. 2 into 10. And 3 at the ones place, 3 into 1. As simple as that. On the other hand, when for the same number I have to write the scientific notation, try to understand it very carefully. Whenever, so I'll write the number 49623. Where is the decimal in this number? If the decimal is not there, it means that the decimal is at the end followed by a 0. Okay, the decimal is not visible to me, so I'll convert it into this. Always remember, whenever you move decimal to one place on the left, whenever you move decimal to one place on the left, it will generate 1 power of 10. So just to give you an example, 49623, decimal is at this place. This can be written as 4962.3 into 10 to the power 1. Since you have moved the decimal on the left hand side to one place, so there is a multiplication of 10 to the power 1. This can also be written as 496.23 into 10 to the power 2. Can also be written as 49.623 into 10 to the power 3. Also be written as 4.9623 into 10 to the power 4. This form is called the scientific notation. Scientific notation is basically you convert the number into a format where there is only one number on the left hand side of the decimal. One digit on the left hand side of the decimal. Okay. What if you move the decimal on the right hand side one place? Then the power of 10 will get reduced by 1. Now, exponent matters more than the digits. So basically, if I want to write down a huge number, for example, if I want to write down Mumbai's population, so where is it used? Mumbai's population, it is this much, right? So basically, this number I have to write again and again. Instead of that, I'll write down in the notation of exponents. Okay. Now, getting a sense of larger numbers, there are numbers which are huge, huge numbers. Okay, like distance between Earth and Sun, distance between Earth and the other galaxy. There are very small numbers. What is the size of an amoeba? What is the size of a cell? That can be written in the negative format. So for example, if I have to write down a number 0.00000081, right? Now, if I have to write down the number in this format again and again it will take a lot of time since it is a very small number. I'll convert it into a number which is in the exponent notation or the scientific notation. So I'm shifting the decimal on the right hand side. So I have to reduce the power of 10 by 1 each time. 1, 2, 3, 4, 5, 6, 7, 8. So to convert it into 8.1, I have to reduce the power of 10 by 8 because I'm shifting the decimal 8 times on the right hand side. Currently, the power of 10 is 0. So 0 minus 8 is 10 to the power minus 8. As simple as that. Okay. Perfect. So I think we have completed the entire chapter of power play. We have discussed what are the different laws of exponents. We have discussed what is the use of exponent. We have discussed there are some very large numbers or very some small numbers which are which can be written in the format of scientific notation, which will help in reducing the effort of writing and maybe to some context to calculation also. So I think that's it. That's for the lecture. So today we understood what are exponents, powers, and we learned some important laws, solved examples. Uh, we tried to understand a lot of quick tricks that can save some time in the examination. So I'll see you in the next video with questions on this topic. In the next video of the same chapter, we are going to solve a lot of questions which are there in the textbook. Until then, keep learning and keep aiming higher. Bye bye.